few of these, and then we're going to skip a few and then go to some others. So we have a spring that is attached to a wall. It is just above a table surface, and we have a mass labeled M, and it is compressed, and it is at letter A. We let go of it, and it starts to move along the table. When it gets to the end of the table, it flies off and goes down to letter D. So the question that we have here is, when I have a system and it is just the block, so if the only thing you saw was the block, and all of a sudden you see the block take off, and then that block tends to turn a direction, we want to know, what is the mechanical energy? What is the mechanical energy? So your choices here are kinetic energy, kinetic and gravitational potential, kinetic and spring energy, or all three of them. So if we only look at the block, so this is really looking at, if we look at this, you're going to see that we're only focusing on the block. We don't know anything about the spring. We know nothing about the earth. We know nothing about the table, and we know nothing about the floor. So the only thing that we see here is just the block moving, and it changes direction, and we don't know why. All right, so let's see what everybody said here. So our answers that you've given are kinetic energy, kinetic plus gravitational potential, and then kinetic plus spring plus gravitational potential. So let's go back and read the question again. If the system is just the block, what is the mechanical energy? Notice that the earth is not there. We don't consider the spring either. So if we don't consider the earth or the spring, or the block, earth, and spring all together, then the only thing that the mechanical energy can be is just kinetic. So that's the only thing it can be. The next question that we have here is, between A and B, the mechanical energy does what? So from A to B, so the block is released at A, it separates from the spring at B. So at A, it has zero velocity, and then it increases speed to B. And Peter is absolutely correct. So this question did come up on the free response, and they were asking about systems. This is one thing that a lot of teachers might not go through a lot. I like to go through it because I always see multiple choice, and if not in multiple choice, we'll see it in a free response question. But they try to make sure that you understand systems. All right, so let's take a look at what your answers are so far. So you're doing really well. It does increase. So very, very, very good. Good job. So this one would increase. How about between B and C? Does the mechanical energy increase or stay the same? Remember, we're only concerned with the block. We don't have the earth, we don't have the spring, and we definitely don't have all three together. So from B to C, does the mechanical energy increase? Stay the same. Remember, the block accelerates from A to B, and then from B to C, the speed is the same. The speed does not change. I think that might help some of you that have answered incorrectly. You're starting to do a little bit better here. Good. Excellent. All right, let's take a look. Yeah, so this one, it does stay the same. Why does it stay the same? Because we're looking at the change in energy. So from B to C, there's no friction, so it is not changing speed, which means that the energy has to remain constant. So friction would play a role in this if we had friction, but notice that there is no friction on this one. So there is no friction. Let's go ahead and take a look at the last one. How about from C to D? I'm going to go ahead and tell you that from C to D, the mechanical energy does increase, but it's not because it's increasing the gravitational energy. It's just speeding up. So we see it speeding up here. All right, let's do this. I'm going to go ahead and move through these next few. And you can kind of see that if I have the block and the Earth now, I can have both kinetic and gravitational energy. But you'll notice we don't have any spring energy at all. So let's go to the first question that deals with the block and the spring. So for this one, if I just have the block and the spring, what would the mechanical energy be? Would it be the kinetic energy only? Would it be kinetic and gravitational? Would it be kinetic and spring? Or would it be all of them? So for this one, what we're doing is we're trying to figure out, is the mechanical energy for this one, for the block and the spring, is it kinetic? Is it kinetic plus gravitational? Is it kinetic? You can't answer this question. That's really weird. All right, cool. So let's just go through this. So this one, it is kinetic plus spring. So I'll have to look at why this one's not working. It does remain constant all the way through, but it increases between C and D. For the last set, since this isn't working real well, we'll see that here is kind of what happens on the last part. So we do have kinetic plus gravitational potential plus spring energy. That means that from A to B, the mechanical energy stays the same. It continues to stay the same from B to C, and it stays the same from C to D. So really, really, really helpful. Hopefully that's helpful. All right. So I'm not sure why those didn't work, but I'll go back and have to take a look. All right. So let's talk about the conservation of energy a little bit. So for this one, if a system doesn't receive energy or give energy to the surroundings, then we know that it obeys the law of conservation of energy. So if there's no work done on the system, or if it doesn't do any work on the surroundings, then we can conserve energy. If there's no forces like friction that convert the kinetic and potential into other forms like heat or dissipated energy, maybe sound, then we definitely have conservation of mechanical energy. So a couple of different ways of looking at this. In equation form, if we think about just the conservation of mechanical energy, then that's the initial kinetic plus the initial potential. And remember, the potential here could be spring energy or gravitational energy or both. And that would be equal to the final kinetic plus the final potential.